Okay, now we're going to start 4-7 inverse trigonometric functions, and I kind of talked about them a little bit in that last section, and possibly I had no sound, but I'll maybe see what I can do there. So today we're going to evaluate and graph inverse sine functions, evaluate and graph the other inverse trigonometric functions, and evaluate compositions of trigonometric functions. So that's kind of the lesson here. The first thing we're going to look at is the inverse sine function. And as we know, for a function to have an inverse, it has to be 1-to-1. And that means it passes that horizontal line test, which the sine function overall does not pass. But if we restrict the domain just to encompass every different value of the sine function, then we can have an inverse of that. And so we're going to restrict the domain from negative pi over 2 to pi over 2, and then we can find inverses. So here's kind of what happens when we restrict that domain. When we restrict the domain from negative pi over 2 to pi over 2, the function for the sine of x is increasing over that whole interval, and the sine of x takes on every single value in its range. And so then that means it is 1-to-1. So once it's 1-to-1, then we can find the inverse of that function. And the two important things you have to know about the naming of inverse functions is we can use this terminology, the arc sine of x or the inverse sine of x, and those are exactly the same. And so the inverse sine notation is a little more consistent with that f inverse of x, and the arc sine of x comes from the association with the central angle and its intercepted arc on a unit circle. And so the arc sine of x there means the angle whose sine is x. You want to know that. You want to know that when you're finding an arc sine, you're finding an angle. So the arc sine of x means it's the angle or arc whose sine is x. And if you kind of remember that, that will help you kind of know what you're looking for. So our answers are often angle measures as we go along there. And this is a nice little picture. We'll actually be graphing the arc sine, so you can just kind of look at this now. The arc sine lies in the interval from negative pi over 2 to pi over 2. And here's kind of the definition of it, and because we'll graph it in just a minute. The definition of the inverse sine of a function is y equals the arc sine of x if and only if the sine of y equals x, where our domain is from -1 to 1, including those, and our range is from negative pi over 2 to pi over 2, and including those. To be very honest, when I think of arc sine, I think of this. All students take calculus, and I think to myself, okay, I'm automatically crossing off those two quadrants, and it's all going to be in this quadrant or this quadrant. And it's going to go from 0 down to negative pi over 2 and up to positive pi over 2. When I draw that picture, it tells me a lot. And notice that sine will be positive in that first quadrant and negative in that fourth quadrant. Also, this allows us to use a lot of times exact trig values as we go through things. And so that's what we're going to look for, is finding arc sines and arc cosines and arc tangents of things that we know exact values for. So you're going to want to think about generating that table in your head that we've kind of done periodically as we've looked at things. So I'm just going to slide this down a little bit and kind of keep keep kind of going through this, reminding myself, since I'm only talking about sine right now, if you remember, those go 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. And this is 0, pi over 6, pi over 4, pi over 3, and pi over 2. And so this kind of gives us our values. Now, when we're looking at this, our x values are going to be here, our domain, and our y values or our range is going to be those different angles, and kind of falling within the two quadrants, the first and third. So we get either a positive or a negative value as we go through. So this should be pretty straightforward. The thing we have to remember is what our domain and our range are. Maybe I'll just go back a second. Remember, our domain is from -1 to 1. It's all the values that sine takes, the sine of an angle takes. So if I try to go find the arc sine of something that's not in that domain, I have to say my answer is undefined. So just look over these three. There's the arc sine of -1/2. That kind of reminds us that it's on our table. The inverse sine of the square root of 3 over 2. That kind of leads me to think it's on that table. The inverse sine of 2. Well, that sends up a red flag to me. Why? 2 is not on the table, and sine oscillates from -1 to +1, and so I can never have an angle whose sine is going to be 2, right? Because if I have any angle I ever look at spinning around over and over and over again, it's either going to go from -1 to +1, because I'm not changing that in any way as I go through that. So as we look at these, and I use this table. All students take calculus. I have that in my head. It's very handy for me. So I'm going to scratch those out. The arc sine is -1/2, so that means it's not going to be in the first quadrant. It is going to be in the fourth quadrant. And then I just figure out what my reference angle is. My reference angle, I just generated that table a minute ago. If the sine of theta is 1/2, then theta is pi over 6. So my reference angle is pi over 6. Since it's down in this quadrant, I have to go down, so it's going to be -pi over 6. So my answer is that the arc sine of -1/2 is equal to -pi over 6. And so I decide whether it's positive or negative, and based on kind of my quadrants that I'm looking at, and then I kind of go from there. My next one, inverse sine. These are all inverse sines. All students take calculus, get rid of those. It's positive, so I'm going to be in that first quadrant. My reference angle for square root of 3 over 2 is, reference angle is pi over 3. And so the inverse sine of the square root of 3 over 2 is pi over 3. And we've kind of done that way back, you know, even when we've known sides and wanted to find the angle, we've used that inverse sine key on a calculator, and it does work as we go through this. This last one, we just want to comment. This is saying that the sine of some angle is equal to 2. The sine is our domain. Here, our domain is from -1 to 1. And so this 2 is not in the domain. So this one is not possible. As we look at that, that one is not possible. I did want to go over another one, and that is the arc sine. We'll call this one ABCD. The arc sine of 1. If I have the arc sine of 1, I kind of go through that same, all students take calculus, it's not those. If you think of those points on a unit circle, they're kind of cosine comma sine. And so the point that I would be looking at would be the one that's up here of 0, 1. And that's also on your table of values. So the arc sine of, oops, the arc sine of 1 is equal to pi over 2. And you know, if it had been the arc sine of -1, it would have been negative pi over 2. And so those are kind of on our table as well as we go through that. And hopefully that makes sense to you. The next thing we're going to do is we're actually just going to carefully graph the arc sine of x. And so we'll kind of look at some values. I'm going to make an opposite sign chart. And so by an opposite sign chart, I mean I'm just going to put the sign on the first line and then the angle on the second line. And then that'll kind of make it easier for me to kind of know what's happening. And I'm gonna write a kind of longer table as well. I'm gonna start with 0 there, and I know this is 1/2 square root of 2 over 2, square root of 3 over 2, and 1. So then backwards, this is -1/2, negative square root of 2 over 2, negative square root of 3 over 2, and -1. So I can get all of those values as I go. And then I'll think about what those are. This is 0. This is pi over 6, pi over 4, pi over 3, and pi over 2. This one goes negative, so negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. So I could generate a fairly decent table as I go through that. And then I'm going to plot some points. Now, personally, I'm not going to plot every point that's on there. I'm just going to plot, you know, a representative piece of points. Also, when I graph this, I want to remember that my domain values are from -1 to 1. So I'll kind of skip a couple marks here and skip a couple there. So there's my -1 and here's my 1. So that's now my domain is from -1 to 1, and my range is from, yes. Oh, thank you. Yes, it's been pointed out to me that I made a mistake on that table. So it's the square root of 3 over 2. And is everything else good? Okay, thank you. So I'm going to go from -1 to 1, and then here I'm going to go from negative pi over 2 to positive pi over 2. And I kind of skipped a couple there too, and there and there. So negative pi over 2, then this is negative pi over 4, 0, pi over 4, and pi over 2. And then I'm just going to kind of plot some points. I think that's -0.8. And so this is 0.8. And I'm not going to graph everything. I'll just try, like, you know, maybe those. We'll see. At -1, I'm at negative pi over 2. At -0.8, which would be, oh, maybe I should do this one. I'm going to do this one instead. I'll do that one instead of this one, because that's, is that 0.7 something? 0.7, -0.7 something, and then it's there. So -0.7, I'm at pi over 4. I'll put that kind of there. At, then I'll just go all the way to, at 1/2, I'm at negative pi over 6. That might be like right here. And then at 0, I'm at 0. At pi over 6, I'm at 1/2. Or excuse me, at 1/2, I'm at pi over 6. And then, pardon? Oh, yes, it is. At 1/2, I'm at about pi over 6. And then again, I kind of want to do the other one here. That's 0.7 something. So at 0.7, I'm at pi over 4. And at 1, I'm at pi over 2. And then I can kind of graph that as well as I can. And that is, by graphing that, physically going through that process, you can remind yourself exactly what that domain and range are. And I think that'll help you as you go along kind of through these. Once you kind of have a concept of the arc sine, the arc cosine, the arc tangent are pretty straightforward. And so I'm going to find where those are. There's the book author's graph of that. I'll find where those are, and we'll just kind of go to this page. And for these now, the arc sine we just talked about. And so all students take calculus. It's in the first and the fourth quadrant. When we look at the arc cosine, though, we go from, all students take calculus, from 0 to pi. So for arc cosine, we use the first two quadrants. Think about why that makes sense. Look at this. In the first quadrant, cosine is positive, correct? In the fourth quadrant, cosine is also positive, correct? So if we use those two quadrants again, we would not get all the different values. Whereas here, the first quadrant, cosine is positive. The second quadrant, cosine is negative. So it allows us to get all of those. Notice that sine and cosine, the arc sine and arc cosine go from -1 to 1, and their ranges are a little different. Notice that the arc tangent goes from -infinity to infinity. Remember when we did the arc sine, was it 2? Of 2, and that was not possible because that wasn't in the domain. Well, if we wanted to find the arc tangent of 2, it would fall in that domain. And so for tangent, maybe I'll use a different color here. For tangent, again, all students take calculus. We're going to use the first and the fourth quadrant using positive and negative values as we go along. Okay, then the graphs are shown here. We already made a nice graph of the arc sine. You might want a little graph of the arc cosine. Notice the difference between these two graphs, and they're not quite lined up the same, so they look very the same. But here, the range goes from -pi/2 to pi/2, and for arc cosine, the range goes from 0 to pi is that range. And then also noticing that arc tangent kind of goes on forever in either of those directions. So in the domain, it encompasses all real numbers. And again, goes from -pi/2 to +pi/2. With the information you have, you can find really the inverse of any trig function. One thing I want to kind of say before I close on this is that when you're using any of this, your calculator has to be in radians.